Okay, I would like you to actually flip back to page 345 with me. This is not one of the ones that's in your homework assignment, but I skipped over it and really I'd like to address this one. It's similar to the one that we looked at on page 344. Number 6 says that Ramona has $18 that she can spend on food for her dog. Dry dog food costs $5.50 per small bag, and wet dog food costs $2 per can. Write a linear inequality that describes how many bags and cans of food Ramona can buy. Okay, so like I have said in the past, for me at least, it makes mental sense to kind of be like, okay, I'm going to write all of the things over here that she can buy or what she can spend. Okay. And all of the stuff she can spend is no more than $18. Okay. So mentally, I'm kind of setting myself up. All of the stuff that she's going to buy has to be less than or equal to $18. Why? Because she only has $18 to spend. Okay. Then I'm going to say $5.50. It really doesn't matter whether I decide that the bags of dog food or the cans of dog food are X and Y, but I'll just do $5.50X. And I'll do plus $2 Y. And when we graph this at the end, we're going to have like our X values here, our Y values here, and whatever my Y value and X value is together is going to be less than 18. So we're going to have something that looks like this. And there's going to be like a bunch of different possibilities. Maybe if I buy 1 and 1, well, that's definitely something I can do because that's less than or equal to $18. But anyway, that's what we're going to wind up with, something similar to that. But let's go ahead and solve for Y so that we can get this graphed. Okay, so what I did is I moved the 550. I recognize that all of this is money, so really I should have 2 decimal places, but just for simplicity, I made it look a little simpler. And then to get Y, I'm going to divide both sides by 2. I'm just going to leave it as 550 over 2x, and then 18 over 2 is 9. Okay. Okay, so we'll graph this on our graphing calculator also, but we're going to graph it by hand first. I started with my y-intercept, which is at positive 9. My slope is negative 550 over 2. 550 divided by 2, last time I checked, was 2.75. So I'm going to go down 2.75 and over 1. Down 2.75 and over 1. Down 2.75 and over 1, that kind of thing. Okay. All right, so I've drawn my line going down, and then I also, just to check, I put 0 in for Y to get my x-intercept, did a little math, and I get like 3.27 for my x-intercept, and that definitely looks like about 3.27 is where it's crossing. So I look like I'm in pretty good shape. Then I need to figure out which way I'm going to shade. Okay. I, again, like picking 0, 0 because it's an easy point to deal with. If I put a 0 in here and a 0 in here, then that's going to wind up saying 0 is less than or equal to 9. And that's a true statement. So yes, I do shade on this side. Okay. Now I want to talk to you a little bit about this graph. This is an actual situation where you're using money for a real world situation. I'm not going to have any negative values over here because I'm not going to buy negative cans of dog food, negative cans of negative bags of food or anything like that. Okay. So In this case, your negative values really don't make a whole lot of sense. So really this only takes place in this first quadrant where I have X values that are positive and Y values that are positive, and nothing goes below 0. Okay. So I could actually take that and just use quadrant 1. All right, so what I've done is I've redrawn our situation on a little piece of grid paper that's only really using the first quadrant. Remember, our solution is on this side of the line. And again, this is a real world situation, so we are bound by like reasonableness. Remember down here, this is our X. This was our bags of dog food. Like I could buy 2 bags of dog food and 2 cans. I mean, I can afford that. I can buy 2 bags of dog food and 3 cans. I can buy 2 bags of dog food and 4 cans. Or no, that's 5 cans. No, it's 4 cans. But I can't, like a point right on the line right here doesn't really make sense because that's just under 2 bags of dog food and it's like 4.5 cans. And I can't, that's not a situation. They're not going to sell me 4.5 cans. They're not going to sell me part of a bag. So like this is a reasonable solution. This is a reasonable solution because those are like whole number situations. Okay. But any ordered pair that falls in this shaded area is a solution to this problem. Just keep in mind that because of the situation we're in, where it doesn't make sense to have a part of a can or a part of a bag, we're kind of limited as to what our ordered pairs would actually be.